Hello guys, welcome to Infinite Loop and another session on data structures and algorithms. So in our previous session we have discussed about asymptotic notations, right? Like we have seen different notations like big O, omega and theta notations, and we have seen basically how we can represent our algorithm in terms of these notations, right? So it was very easy, and we have seen like there are few rules and conditions which we must see before writing the time complexity in terms of big O or omega or theta notations. And also I have said that in most of the cases, like most of the algorithms will try to represent it using big O notation. I haven't told you the actual reason why we will represent it in big O notation, but in this session we will try to discuss about that, and also along with that we will discuss about the best case, average case and worst case analysis. So what basically these, what are these cases and how we can represent an algorithm, like how we can say this is best case or this is worst case, something like that. So we'll see those things in this session. uh, Before discussing about this best case and average or and worst case, let's try to take an example, and from that example we will derive this best, average and worst case. Let's say you are given with an array. Okay, you are given with an array which contains elements like 5, 1, 4, 3, 2. That's it. Okay, this is an array. So you know that array looks something like this, right? Here it is 5, here it is 1, here it is 4, here it's 3, and here it is 2. So this is the indexing 0, 1, 2, 3 and 4, right? Let's say you are given with an array, and the question is to find a particular element present in the array or not. Let's say I have given to check 3. You need to check that whether 3 is present in this array or not. You can clearly see 3 is present in the array. So if it is present in the array, then you need to return something like true or something like 1. If it is not present, then simply return 0. Okay, that is the idea of this problem. I hope you, by listening to this discussion, you got to know what is this problem. This is basically a linear search. We will discuss about this linear search in detail in our upcoming sessions while discussing about searching and sorting algorithms. But basically this is called as linear search. What we will do is we will linearly check for each and every element whether it is present or not. Okay. So let me do a dry run. Like uh, let's say the idea is to check for 3, right? First I will check at 0th location. Is 3 present or not? No, it's not present. Then simply increment. Again check at 1th location. Is 3 present? No. Again check at 2nd position. No. Again check at 3rd position. Yes. You can clearly see 3 is present in the array. So you can see like we have come a long way, like, right? So we have incremented our something pointer like thing, and we have came here and we got to know that 3 is present, right? So this is the basic, agenda or something related to linear search. Okay. Now, what is the discussion? Our discussion is about best case, average case, and worst case analysis, right? So basically, the array looks something like this. Uh, let's say this is the array, right? There are some, how many, whatever may be the number of elements. In this case, we have seen that 3 is present at 3rd position. That means somewhere here, right? 3 is present here. There might be a case that 3 might be present here as well, or there might be a case that 3 might be present at this place or this place or this place or any place, right? It depends on the array that is given for you, right? So let's say if 3 is present in the first location itself, then there is no necessity or there is no requirement of checking the remaining portion of the array, right? Because you got 3 at the first location itself. That means this is the best location, right? You found the element, that is the element equal to 3 at the first location itself. That means this is a best location. That means this is a best case. This is a best case, right? You have seen it only in one, something like one pass or something like that, right? Just you came to check in this array, and the first position itself you have decided that 3 is present. So that is the best case. That means it's something like, you have a bag, let's say you have a bag of different balls. Let's say there are red balls, blue balls, green balls, something like that. And your idea is to find out a red ball from this bag. Let's say by God's grace, by picking up the first ball only, you got it as a red ball. So that is the best case, right? That means it's a best possibility that you can get. So that is about best case. Okay, let's say what is worst case. Worst case could be the element will be present at the last position or the last location. That means you are checking the array, you are checking the array, you are checking, and at last position you have seen that the element is present. That means here there is a important requirement to check the entire array. You just can't blindly check at the first location and go to the next, don't go for the next locations. Here you need to check each and every location because the element is present at the last position. That means this is a worst possibility because here you are required to search for each and every position, each and every, what we say, each and every location. You need to check whether this 3 is present or not. So that is the idea of worst case, right? So basically best case in the sense, in the first position only you got to know the, you know the element is present. In the worst case it is the last position, right? Then what could be the average case? Can you guess? Average case could be something like average. That means let's say in the middle of the array, like you have found 3 here. So it's something like an average or middle, right? At middle position, we have found the element, right? So these are the 3 different cases that you can, encounter while writing any algorithm. Okay. So we have seen what? We have seen best case, we have seen worst case and average case. Now let me try to make it once again. Okay, this is the array. So we have said if you find the element at the first position only, then that's the best position, right? Best position. And if you find somewhere like in the middle of the array, then that's an average position. And if you find at the last position, okay, then it's a worst thing. That means here you need to take some extra responsibility, like you need to check each and every location and you need to go till the end of the array, right? So that's why we are calling it as worst thing. Now based on this, can we derive the complexity in terms of big O? Like derive the complexity for best position, derive the complexity for average, and similarly for worst position. In the best position, you can clearly see that in, one step only you got to know that element is present. That means literally it's taking something like one constant time. That means in one go only you got to know that the element is found, and you have seen that it's a best case, and that's why I'm writing it as big O of 1. That means it's a constant one, right? And for worst case, let's say the array is, array can be of length 4, array can be of length 5, or array can be of length n. So if the array length is n, let's say, right, array length is something over n, then what you need to do? They need to check till n. That means till the last position, you need to check whether the element is present or not. Let's say you have done some so much hard work and you got to know that the element is present at the last position. That means at the nth position, something like that, right? The nth position. Then for worst case, you are writing something like big O of n. That means you must and you should check all the elements. That means till n. Till n, you need to check. The entire array must be seen to find out whether that element is present or not. And what could be the average case? It is simply like half of n. That means you can get at middle of the array, right? It's not like too here or too much here. It's somewhere over middle of the array. So that's why I'm writing it as big O of n by 2. So with this linear search, I hope you got some, basic idea about what this best case, average case, and worst case, right? Now while doing or while solving problems related to data structures and algorithms, right, while learning data structures or algorithms, our main agenda is what? To solve the problems, right? So while solving problems, we have seen that time complexity is a very crucial thing, right? Let me change the color. So we have seen that time complexity is very crucial, because without this time complexity you basically cannot write any algorithm, right? So we have seen we can represent time complexity in three ways: big O and omega and theta notations, right? And we are telling that something, there are different cases like best case, average case and worst case. For any algorithm, these are the maximum cases that you can have. So generally we represent this big O, right? Generally we say that this big O represent for upper bound. That means it is for worst case. Of course, you can write big O for best case, average case and worst case, but basically we will do a combination of big O plus worst case analysis. While writing any algorithm, right? While writing any algorithm, we do a combination of these two things. We will use big O notation and we will try to solve that problem in worst case. That means worst case in the sense, if you have an array, then the worst case could be what? The worst case could be searching entire array, right? Let's say if there is something like stack, generally stack is also a data structure, then you need to search entire stack. Let's say there is a tree, okay? In worst case, you need to search entire tree to find the element or to solve any problem, right? So for solving any problem, right? Solving any problem, right? You basically require what? You basically require this big O notation. Of course, you can use any other notation, but uh, generally, as a part of DSA, right, we generally use this big O notation, and we'll try to find out the worst case analysis. That means we'll try to find out what is the worst possibility or the worst time that the algorithm or the code takes. Okay, so that is about this analysis. Okay, best case, average case, worst case analysis, and we have seen asymptotic notations as well, right? So that was about some important details about time complexity, right? So in our upcoming sessions we will try to discuss or we'll try to solve some codes or algorithms, and we'll find out time complexities for them. Okay, let's say I've given you one code snippet and you need to tell what is the time complexity of that code snippet. So in that way we'll try to do some one or two videos. So that was about this session, guys. Hope you have learned many things, right? Like we have seen linear search, and we have seen what is the you know case analysis, best case, average case, worst case, and we have seen worst case is an important thing, right? And we have also learned linear search, right? We have got to know what is linear search. Like we are checking each and every each and every step, each and every element in the array, we are simply doing a check, right? And we have seen best case in the sense at the starting only you got the element, and worst case in the sense is the worst possibility. That means you are doing a huge a time taking job, and average in the sense it's something over middle of the job, right? So for DSA, as I said, big O notation is important, and you need to you need to build your algorithm as a worst case. That means you need to form an algorithm which is of worst case time complexity. Okay, so that was about this video, guys. Thank you for watching this video. If you like the content, please like, share and subscribe to this channel, and also hold the bell icon. And of course, if you are new to this channel, you can visit my playlist, right? You can go into the data structures and algorithms and you can watch the videos in this playlist. I have done literally about 6 videos, and this will be our 7th video. So it contains a great information. So if you try to learn this information and give me a motivation by subscribing, it means a lot. So that was about this session, guys. Thank you.